back, everybody. 1.6 phosphorus cycle, another one of our biogeochemical cycles. We finished up carbon, we finished up nitrogen. Now we're on the phosphorus. I'm not going to lie, there's still 2 more to go after this, but we're moving along. We're doing great. This is going to be a really short one, so don't worry too much. Again, standards, things you have to understand about the phosphorus cycle that we're going to cover. Again, if I don't cover something to the best of your ability that you feel you don't know it, shoot me an email. I'll gladly get to it. Here we go. Phosphorus cycle in a nutshell. It's similar to nitrogen in that phosphorus is a limiting nutrient needed for plant growth. It's needed for plants to be able to go through photosynthesis and to be able to create the biomass that's needed for all life, all the food chains on the planet. If it is in excess, it is actually going to be, again, creating those conditions where you can get large algal blooms and various other things like that. There's actually a lot of states now that are putting laws in place to stop you from using phosphorus at certain times in the year, especially in the fall, because what's doing is it's messing with the ecosystems, especially the aquatic ecosystems, because everyone's lawn seems to have to be fertilized, and then all of a sudden that fertilizer runs into the local waterways and then leads to other problems down the road. Phosphorus commonly exists as ionically bonded salts, commonly existing as phosphates. So a lot of our different phosphate compounds are often what we refer to as phosphorus, especially, or what we use when we talk about phosphorus. The one thing about the phosphorus cycle, it doesn't use the atmosphere at all. It's all based on water and land interactions. No phosphorus ever gets up into the atmosphere. So it's not like we're talking about phosphorus existing as a gas or phosphorus falling to the earth as phosphoric acid or something like that. No, it is all based on just being in rocks, weathering, erosion, exposing that phosphorus. Then as it rains, the water flows over the rocks, dissolves the phosphorus, and brings it into a local waterway or across a field and deposits it. Therefore, plants get it to grow. And that's the big thing I want you to understand. Most of these phosphorus salts are very, very soluble, and they will allow it to dissolve and cycle throughout the atmosphere. So here's a look at the phosphorus cycle, a very simplified cycle. All right, so let's quickly go through. Again, it never gets to the atmosphere. So that's a big thing to understand about the phosphorus cycle. It never gets into the atmosphere. But let's talk about just a plant, starting with a plant. So a plant is going to be pulling phosphorus that's found in the ground. All right, maybe it's applied as a fertilizer. Maybe it's just a naturally occurring compound in an area, very trace amounts, because if it was in abundance, you would see a lot of plants growing in that area. It's then going to be brought into a plant or an animal. Animals will then decompose or waste will be full of it. So actually, animal waste is oftentimes very full of fertilizer compounds. So nitrogens and phosphorus compounds. Those are very common in animal waste. So things like manure can be used as a fertilizer. Bird droppings, bat droppings, which are known as guano, are great nutrient-rich fertilizers that are all just naturally excreted from organisms. So eventually that phosphorus will probably cycle around. Decomposers can release it back up into plants, or it might get transported into a local body of water, where then eventually it will deposit, and over millions of years through geologic uplift and erosion be exposed, and then eventually weathering, water flowing over it will dissolve it, pick it up, and transport it somewhere else. Very, very simple cycle. But phosphorus is also often can be found in excess because of fertilizer applications, and then it leads to problems in ecosystems. So it's something I want you to be aware of. I want you to understand that phosphorus at normal levels, great, but in excess can be very, very problematic because it can lead to advanced plant growth, which doesn't sound too bad, but in aquatic ecosystems can be incredibly detrimental to the whole health of the ecosystem. With that, I finished the phosphorus cycle. Hopefully it was as short and as sweet as you had intended it to be. Hopefully you are ready to keep moving forward. Hopefully I am not too boring, but too bad. So If you have any questions about phosphorus cycle, any questions at all, feel free to shoot me an email. Otherwise, I'll see you at the next lesson.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now. Go ahead and comment. Tell all your friends about how great that lesson was. And make sure you subscribe, because I'm going to keep bringing you AP environmental content that you're going to want to watch. Or do whatever else those other YouTube channels tell you to do. And with that, Maloney, out.